Hello, hello and welcome to this video. In this video, we will solve 10 more problems on polynomials and equations. Till now, we have solved problems till 150. So we will solve question number 151 to 160. And as always, I will say that when I'm stating the problem, you should pause the video. And if you cannot solve the problem, then look at the solution. So question 151 says that the product of two of the four roots of the equation x to the power 4 plus 7x cubed minus 240x squared plus kx plus 2000 is equal to 0 is minus 200, find k. So this is a very straightforward problem. We let alpha, beta, gamma, delta to be the four roots such that alpha, beta is minus 200. It is given that the product of two roots is minus 200. And then we apply Vieta's relations, alpha plus beta plus gamma plus delta is equal to minus 7. Alpha beta plus beta gamma plus gamma delta plus alpha gamma plus alpha delta plus beta delta is equal to minus 240. Alpha beta into gamma plus delta plus gamma delta into alpha plus beta is equal to minus k, and alpha beta gamma delta is equal to 2000. So this is 2000 and alpha beta is minus 200. So gamma delta is minus 10. Once we know gamma delta is minus 10, we substitute alpha beta and gamma delta in this. It becomes gamma plus delta plus 200 gamma plus delta into 10 into alpha plus beta is equal to k. Okay. So here there is a minus sign here. Gamma delta is minus 10. So all the minus signs are eliminated, and then we from this is 30. So alpha plus beta and into gamma plus delta is equal to minus 30. Okay. And gamma plus delta whole square plus 7 into gamma plus delta minus 30 is equal to 0. So it gives us gamma plus delta is equal to minus 10. Once we have gamma plus delta, we have alpha plus beta, that is 3 or minus 10. This is minus 10 or 3, so alpha plus beta will become 3 or minus 10 from this relationship. All right. Once we have that, we have k, which would be either minus 1970 or 500. We substitute in this both the values and we get the value of k. Now we look at question number 152. The product of two of the four roots of x to the power 4 minus 20x cubed plus kx squared plus 590x minus 1992 is equal to 0 is 24. Find k. So it is a similar problem. So we let the given quadratic equation to be equal to, sorry, not quadratic, or it is of degree 4. So we let it to be the product of two different quadratic equations, x squared plus ax plus 24 and x squared plus bx minus 83. So we factorize this. Okay. Now the product of two roots is 24. So we know that one of the terms, that is this term, product of two roots would be 24. So the other one is automatically minus 83. Once we have this, we compare the coefficients. We have a plus b is equal to minus 20, ab is equal to minus 90. Oh, sorry, ab minus 59 is equal to k. 24 b minus 83 is equal to 590. So we have 1, 2, and 3 equations and 3 unknowns, a and b and k. We solve these, we get a is equal to minus 10, b is equal to minus 10, and k is equal to 41. Okay, now we solve question 153. Let a, b, c, d be any four real numbers not equal to 0. Prove that the roots of the polynomial f of x is equal to x to the power 6 plus ax cubed plus bx squared plus cx plus d cannot all be real. So we let the roots to be x1 through x6. So from Vieta's relation, sigma of xi is equal to 0 and sigma xi xj is equal to 0 and sigma xi square is equal to 0. All right, because the powers of 5 and 4 are 0. So since xi is 0, sigma xi is 0 and sigma xi xj is 0, that will mean that sigma xi square is equal to 0. Okay. However, if all the roots are real, then sigma xi square cannot be 0. So how sigma xi square is equal to 0 is that this whole square minus 2 of sigma xi xj is equal to sigma xi square. So if these two are 0, this will be 0. And if all the roots are real, that is these roots, all roots x1 through x6 are real, then sigma xi square cannot be 0. But this is a contradiction and therefore all the roots cannot be real. Question 154 says that if A, B, C, and P, Q are real numbers, such that for every real number x, ax square plus 2bx plus c greater than equal to 0, px square plus 2qx plus r greater than equal to 0, then prove that apx square plus bqx plus cr greater than equal to 0 for all real x. So these two quadratic expressions are greater than 0. That means their corresponding discriminant would be less than 0. Okay, because P and A are positive here. So corresponding discriminants are 0. That means B square minus B 4B square minus 4AC will be less than 0, which is essentially B square less than equal to AC, and similarly Q square less than equal to PQ. Now we multiply these two, we get B square Q square less than equal to 4 ACPR, sorry, ACPR, which implies that B square Q square less than equal to 4 ACPR. Now, how did we get this? Okay, so if you multiply these two, we get B square Q square less than equal to ACPR. Now, how did we get the number 4? That is the question. So if it is less than this, then of course it is less than this, because when you this term is already greater. So if you multiply by 4, then of course it would be even greater. So once we have this, we know that b square q square minus 4acpr would be less than equal to 0. And therefore apx square plus bqx plus cr greater than equal to 0. Just like we came forward here, we go backwards here. Question 155 says that find the necessary and sufficient condition on the natural number n. For the equation x to the power n plus 2x to the power n plus 2 minus x to the power n is equal to 0 to have an integral root. So, okay. So we let p of x is equal to this. First we assume n to be even. If n is even, then p of x becomes 6x to the power n and so on plus 2 to the power n plus 1. From rational root theorem, if there is a root p by q, then p must be plus minus 1 or plus minus 2, and q plus minus 1 and plus minus 3. Since we need integral roots, therefore p by q is equal to plus minus 1. Now p of plus minus 1 is 2 plus 3 to the power n not equal to 0. So our assumption is wrong and n is an odd number. Once it's an odd, since x is odd, then px is odd. Okay? Hence, x must be even. So if you look at this, then x is odd. All right? So this is odd to the power odd, and this will be odd to the power odd, and this will be odd to the power odd. So px is odd, and hence x must be even. Let x is equal to 2y. So q of y is equal to p of 2x by 2 to the power n, which gives us y to the power n into 1 plus y to the power n plus 1 minus y to the power n is equal to 2 plus and so on up to y to the power n. Again, from rational root theorem, y is equal to plus minus 1 or plus minus 2. The values of q of y for these values are 3 to the power n minus 2 to the power n minus 1, 2 to the power n minus 1, 2 to the power n plus 1, 3 to the power n plus 2 to the power n minus 1. None of these values vanish when n is equal to 1, which is our first case. When n is equal to 1, p of x is equal to x plus 4. And hence x is equal to minus 4 is the only solution. Now we look at question number 156. Given that alpha, beta, and gamma are the angles of right angle triangle, prove that sine alpha into sine beta into sine alpha minus beta plus sine beta into sine gamma into sine beta minus gamma plus sine gamma sine alpha and so on is equal to 0. So the equation is symmetrical. If you look at this equation, this is a symmetrical equation. So we can assume gamma to be 90 degree, alpha is equal to theta and beta is equal to 90 degree minus theta because they are angles of a right angle triangle. So in the right angle triangle, we assume that gamma is 90, then other ones could be theta and 90 minus theta, and we substitute the values in there and it becomes 0. You see, the first term becomes minus sine theta, cos 2 theta, because this third term is alpha minus beta. So alpha minus beta is 90 degree minus 2 theta. Okay, alpha minus beta. There is a typing mistake here. Alpha minus beta. Yeah, so it is 2 theta minus 90 degree. This is correct. No, there is no typing mistake here. The second term becomes cos theta into sine minus theta. Cos theta into beta is 90 minus theta. So sine beta becomes cos theta. And sine gamma is 1. And sine beta minus gamma is beta minus gamma. Okay, beta minus gamma would be minus theta. Yeah. So you can do the calculation and you will find out that it is equal to 0. If there is a typing mistake, let me know in the comment. Question 157 says that suppose A, B, and C are three real numbers such that the quadratic equation x square minus A plus B plus C into x plus AB plus BC plus C is equal to 0 has roots of the form alpha plus I beta, where alpha greater than 0 and beta not equal to 0 are real numbers. Okay. The roots of the form alpha beta are real numbers. So that numbers A, B, C are all positive and the numbers square root of A, square root of B, square root of C form the sides of a triangle. So because the roots are complex, it is of the form alpha plus I beta, where I is the imaginary number, square root of minus 1. So since these are complex, the D or discriminant must be less than 0. So A plus B plus C whole square minus 4AB plus BC plus CA should be less than 0. That is A square plus B square plus C square less than equal to 2 into AB plus BC plus CA. Now since A, B, C are real, so A square plus B square plus C square must be greater than 0. That means 2 alpha is equal to A plus B plus C. So if you sum the roots, then it would be A plus B plus C, okay? Because it will be 2 alpha. So 2 alpha is A plus B plus C. That means A plus B plus C greater than 0, because it is given that alpha is greater than 0. So A plus B plus C and A square plus B square plus C square greater than 0. That implies that A, B, C are greater than 0. So without loss of similarity, we can assume that A is less than equal to B less than equal to C. So if we can prove that square root of A plus square root of B greater than equal to square root of C, then that should be enough. So from here, we put square root of C is equal to 2 square root of AB, which is greater than equal to C. So we square both sides essentially. Okay. Now, if we have this, we can say that 4AB, that is, we square this again and bring AB to the other side, and C minus A minus B, you square that, we get A square plus B square plus C square plus 2AB minus 2BC minus 2CA. So here what you can do is you can add 2AB and subtract 2AB this side and bring BC and CA to the other side. You will see that 4AB is greater than 0. So this is essentially greater than 0, which implies that square root of A plus square root of B greater than square root of C. And therefore, they form the sides of a triangle. Okay. Now we look at question 158. Find the number of quadratic polynomials A square plus BX plus C where ABC are distinct and ABC belong to the set 1 through 999, and x plus 1 divides X square plus BX plus C, that is x minus 1 is a root. So since x plus 1 divides this, so x minus 1 is the root, therefore a minus b plus c is equal to 0 or b is equal to a plus c. Now clearly, so here a, b, c are these integers, okay? So clearly b will be greater than 2. So we observe that b is equal to 3 or 4, then we have two pairs of solutions for a and c. For b is equal to 5 and 6, we have 4 and so on. So this becomes an AP, and adding that will give us 498,002. Question 159 says that show that there are infinitely many pairs AB of relatively prime integers, not necessarily positive, such that both quadratic equation x square plus x plus b is equal to 0 and x square plus 2x plus b is equal to 0 have integer roots. So we are given two equations, a square plus 2x plus b is equal to 0. That means discriminant is equal to a square minus b. So it would be 4a square minus 4b. Square root of 4a square minus 4b. So there should be a square root sign here and to outside it. In any case, so we let it to be a minus k whole square, which is equal to a square minus 2ak plus k square. So b is equal to k square minus 2ak. So we have discriminant of the first equation as, that is this equation, okay, a square minus 4b. We substitute the value of b from here, it becomes a minus 4k whole square minus 3 into 2k whole square. Thus, we can say that there are infinite number of rational points on x square minus 3y square is equal to 1, such that AB is relatively prime, then it is true. Now we choose 2, 1 as AB, which are relatively prime. The infinite number of points given by intersection of the curve with y is equal to m into x minus 2 plus 1, where m is in the set of rational numbers. So that's how we prove this. Question 160 says that if the magnitude of the quadratic function f of x is equal to x square plus bx plus c never exceeds 1 for x in between 0 and 1, prove that the sum of magnitudes of the coefficients cannot exceed 17. So we are given that, okay, x lies between 0 and 1. Okay? So we substitute x is equal to 0, 1 and a half. So when we substitute 0, c becomes less than equal to 1, because the magnitude never exceeds 1. So c is less than equal to 1. When we substitute 1, a plus b plus c less than equal to 1. And when we substitute half, it becomes a plus 2b plus 4c less than equal to 4. Now from these, we get that b plus 3c, we subtract this from this. So we get b plus 3c less than equal to 5. That means b is less than equal to 8. So a plus b plus 3c less than equal to 3. And therefore mod of a is less than 8. And therefore mod of a plus b plus c less than equal to 17. Sorry, this is mod a plus mod b plus mod c less than equal to 17. So we have mod a 8, mod b 8, and mod c 1. So 8 plus 8, 16, and 172. All right. So with this, we come to the end of this set of questions. I think that if you have questions, particularly on this one, because I have not explained it in much detail, make use of the comments and I will try to explain this a bit more, or maybe in a video I will add more explanation of this. And perhaps I made a mistake over here, which I will review. The mistake was over here. Okay. So I'm not sure about this line actually. If x is odd, then px is odd, hence x must be even. Let me review this and I'll give you condition. Okay. So we had assumed n to be even. Okay. So n was not even, that's what we had concluded. Okay. Now if x is odd, then this entire term becomes odd. Hence x must be even. Is it given that px is even? That's all. Okay. So I'm not sure about this. It has been some time since I did this. Okay. Okay, I will get the explanation of this line probably in next video. Okay. Why x cannot be odd? That is the question. All right. So I'll get the answer of this one in the next video, this particular line. Okay. It has been quite some time since I solved these problems. So excuse me for this inability to explain this line. And for 159, if you need more explanation, make use of the comment box. So I hope that you have found this video useful and informative. And please subscribe to the channel and like the video. There are two reasons why I ask this. The first one, as you know, will increase the reach of videos, and I want videos to reach as many people as possible. And the second is that it motivates me to make more such video. So thanks a lot for watching. Enjoy.